This is question 13, page 385, exercise 17b. So it says a variable has a normal distribution, so we start off with our standard normal distribution, mean average, and that's supposed to be in the centre. And it says we have a mean that is 7 times its standard deviation. So the mean is equal to 7 times its standard deviation. The question goes on to say, what is the probability of the variable taking a value? So what is the probability of a variable taking a value that is less than 5 times the standard deviation? So that's what we're ultimately trying to find. So we start off by asking ourselves, what does a normal distribution look like? Well, it takes the form of mu, comma, sigma squared, which is obviously the variance. And we are given our specific normal distribution, which in our case mu is equal to 7 standard deviations, and we're just going to keep our standard deviation or variance as it is. And we want to know the probability of getting less than 5 standard deviations. So rewriting our normal distribution tells us that our mean average is now 7 standard deviations, and we are looking for this specific value at 5 standard deviations, and it's less than that. Okay, so we know by the symmetry of the graph that our negative z value, and the reason I know it's a negative z value is because if the mean average is 7 standard deviations and we're looking at 5 standard deviations, it must be less than that or to the left. So by the symmetry of the curve, that z value, the negative z value here, is the same as the positive version of that z value, which is there, the same distance away but positive. This distance between 5 and 7 standard deviations is 2 below, so the same z value above that would be 2 standard deviations above 7, which indeed would be 9 standard deviations. So instead of 7 take 2, we've gone 7 plus 2 to get 9 standard deviations. But currently it says equal, and clearly the areas are not equal, so the way I'd make them equal would be to do 1 take away that area. So if I did 1 subtract that area, they would now equal each other. And then we can just go ahead and plug in our z values. So we start off with z is equal to x minus mu on sigma. We know that that's now equal to 9 standard deviations. Take 7 standard deviations from our x value, which is 9, our mean average, which is 7, all divided by sigma, giving 2 standard deviations on sigma, and cancelling through just leaves a z value of 2. Not forgetting that once we've found phi, or we've looked up 2 from our calculator or our tables of 2, we know that that's going to equal 0.9772, but we said that we don't want this positive area, we want the small bit at the end, so hence we need to do 1 subtract that, 0.9772, to give 0.00228 as our final answer.